Hello everyone, I am Dr. Mehdi Teimouri and I will present our paper titled The Effect of Network Environment on Traffic Classification. The presentation is divided into three sections. First, problem statement. Second, dataset and classification model. Finally, classification results and discussion. We can mention four main challenges in mobile traffic classification. Ground truth, which is the data available with their ground truth for this research topic, which is very limited. Scalability is another challenge. By scalability, we mean generalization of classification model to other data sets. This is a topic which is focused in this paper. Also, adaptivity, which means that we need to provide models to cover the dynamism and evolution of the networks. This is another topic which is focused on in this paper. Finally, validation. The solutions require correct validation, which means we should test our models to ensure that the performance is okay. Traditional techniques for mobile traffic classification have some main issues. First, encryption and security, such as SSL and TLS, makes it impossible to have access to the content of the data. Second, shared libraries and content delivery networks makes similarities between different applications. And finally, the evolution of the mobile networks and dynamism of them is a problem, is a challenge. To overcome these challenges, in this paper, we focus on feature extraction and feature selection phase. We believe that this is an important step in overcome these challenges. The main question which is asked in this paper is that how different network environments can affect the performance of an machine learning model for classification tasks. Common features of network traffic can be categorized into two different categories: packet-based features and flow-based features. The above mentioned features depend on network environments such as location, geographical location, I mean mobile devices, app version, users' behavior, or user habits. And we think that a small change in any of these environmental parameters can change the distribution of the features, so it can confuse the machine learning models. To investigate the environmental effects of the networks, we have collected a data set as follows. Our data set consists of 5 separate data sets that were collected by 5 different human users, our students in the lab. They had different mobile devices. They were in different geographical locations. This was to ensure that a realistic traffic is captured. The data set consists of traffic of 60 mobile apps. They were 60 popular and free apps in Iran from 16 different categories. These apps were selected from Google Play Store and 2 major Iranian Android app markets, that is Cafe Bazaar and Market. The data set was collected from October of 2021 to January of 2022. The table shows the 5 dataset specification. And mobile devices and Android version, the number of packets and fellows collected. We derived 54 statistical features for each flow, which is mentioned in this slide. To choose a machine learning based traffic classification model, we have plenty of machine learning methods that are used in classification tasks. Classical models such as decision tree, neural networks, Bayesian models are a choice. Advanced machine learning models such as incremental learning and reinforcement learning or ensemble techniques, which are very popular, as another choice. And in recent years, deep learning methods have replaced the machine learning methods in most literature. The main feature of deep learning methods is the lack of feature extraction steps, which makes it suitable suitable choice in many situations. But they are very complex and they need large data sets. An experiment was done in reference of 29 in which is mentioned in the paper. It is shown that in many cases random forests provides equal or sometimes better results than deep learning models. Therefore, in this article, we have chosen the random forest model as one of the most well-known machine learning models. First, we report the performance of random forest on each data sets separately. As can be seen, the accuracy of models fluctuates between 49 and 59. The relatively high results of data sets of E compared to other data sets indicates that increasing the ability of security and privacy protocols in new mobile devices can decrease the performance since data sets of E is an older data set. The last row of the table shows that combining all 5 data sets for training and testing the random forest model did not improve their results. To assess the impact of different network environments on app classification, we do 3 test scenarios. In scenario 1, we investigate the impact of mobile devices, Android, and user behavior. We use each data set as a training set and test the random forest model against other datasets. In each row of the table, one dataset is used to train the random forest model, and the 4 other datasets are tested, and the average results are given. As it can be seen, the accuracy is reduced to half of the baseline results. The huge difference between datasets of E with others point the need for a machine learning model of continuously updated training dataset. In the second scenario, we examine the effect of combining datasets for training data. We use the data combination of 4 datasets to train the RF model and test the model on the 5th dataset. The results have slightly improved, but by around 10% compared to the first scenario. In other words, the use of data collected in different network environments for training the model can improve the performance of the model to some extent, but we still see a significant decrease in the performance compared to the baseline results. Again, the dataset E with low Android, with old Android still has more negative effect on the performance of the model. In the first 4 rows of the table, where dataset E is one of the training datasets, it probably has a greater effect than the others in reducing the accuracy of the model. Also, in the 5th line, dataset E is used as the test data set. We see the inability to identify the traffic of old Android when the model is trained with the updated devices. This is a two-way street. In the Third scenario, we investigate the model impact of changing the network infrastructure on the performance of the model. We use an external dataset for comparison in this scenario. External datasets are obtained from the App Scanner article, which was collected in another country and under different conditions. These datasets and our dataset had 13 mobile apps in common, which are shown in the table on the right. Therefore, the traffic of these 13 common apps has been extracted from our dataset and placed in separate datasets. We call it M13. First, let's see the result of random forest model on the external dataset. The better performance of the random forest model on external datasets compared to our dataset is observed here. It is because the external datasets have been in a pre-processing step. Noise and mobile background traffic are cleaned, but in our dataset, noise and background traffic have not been removed. Next, to investigate the effect of network infrastructure on the model, we run a cross-validation investigation between our datasets and external datasets. The accuracy of the random forest model has decreased to less than 10%, and practically the performance of the model is even lower than a random model. So changing the network infrastructure has a strong negative impact on the performance of the machine learning model. A model that is trained with the data that is collected in one geographical region cannot necessarily be used to analyze and classify traffic in another country or region. We have our conclusion in this slide. First, we can say that the performance and efficiency of machine learning models such as random forests are strongly influenced by network environmental parameters such as mobile devices, mobile operating systems, user behavior, and network infrastructure, especially mobile operating systems and network infrastructure. This is due to the strong dependency of the selected features on the network environment. Also, the use of the combination of collected traffic on different network environments can lead to some improvement in the performance of the model, even if the model has access to such traffic from different sources and environment conditions. Due to nature of the machine learning methods, this variety of traffic ultimately leads to model confusion and degradation of efficiency. Our conclusion, our final conclusion is that the current features and feature extraction methods are not feasible in real world. Therefore, with dynamism and constant evolution of modern networks, the need to extract scalable and robust features is very necessary for future works. Thank you, everyone.